Just write this question. If the volume of a block of metal changes by 0.12%, which means what they are specifying is the change in volume to the original volume, right? Change in volume to original volume. This is what they specify. Change in volume to original volume. So this percentage is given as 0.12%, which means it is 0.12 by 100. Right? When it is heated to 20 degrees, which means your delta T is 20 degree centigrade. What is the coefficient of linear expansion? So the question is, what is alpha? Now, how will I find alpha? We know that gamma is equal to 3 times alpha, or alpha is equal to gamma by 3. So in case if you have to find alpha, right, boss, I need to find what is gamma. Is that clear, boss? I need to find what is gamma. So what is the formula for gamma? It is gamma will be equal to change in volume divided by original volume into delta T. But you very well know delta V by V1 is given. Delta T is given. Substitute and find what is gamma. It will be per degree centigrade. Once you find gamma, you find what is alpha. That will also be degree centigrade. Will you calculate this?
Yes, ma'am.
What's the value, boss? What is gamma? What's the value for gamma?
Ma'am, like 0 point, then 4 zeros, and then 6.
0.5 10 to the power of minus
3.
0.
0.06 into 10 to the power minus 3.
Wait. 0. Fine, 0.06 10 to the power of minus 3.
Minus 3. Yes, ma'am. I got that.
Okay, correct. Then in that case, it's 16 to 10 to the power of minus 5. Are you getting this, boys? Others?
Yes, ma'am.
Okay, then what will be alpha? Should I
raised to minus 5.
Yes. Should I work for the others? What should I do for the others? So what is alpha? Alpha is equal to gamma by gamma upon 3. So that value will be 2 into 10 to the power of minus 5.
Yes, ma'am.
Others, are you getting these values? Shamshul, Hitesh? Yes.
Ma'am, it's 6 into 10 raised to minus 5 because 0.12 divided by 100, right?
Yeah.
Okay.
Austin, Derek, Dheeraj, Austin, Derek, Dheeraj. Are you getting these values, boys, or should I work out? Should I work? It's mere substitution.
We got one.
It's just, you got it, okay. So shall I go for the next one? Shall
Yes,
I go
ma'am.
for the next one? Okay.
Yes, ma'am.
The next one, this is your textbook numerical. Look at the question. A blacksmith fixes iron on the rim of a wooden wheel of a cart. The diameters of the rim and the iron ring are 5.243 meter and 5.231 meter respectively at 27 degrees centigrade. To what temperature should the iron ring be heated so as to fit the rim of the wheel? Boys, you very well know what is called the rim of a wheel. You know what is the rim of a wheel,
Yes,
right?
ma'am.
Now,
Like the
suppose
outer.
the question is, yeah. So now if I take this as your rim of the wheel, so this rim of the wheel has a diameter. So let the diameter, let me take it as D2. So it is 5.243 meters. Now the temperature is T1 is 27 degrees. Now you have an iron ring. So now let me take an iron ring. Now this has a diameter of say D1, 5.231. So it should not be so much difference should not be over here anyway. The diagram shows lots of difference. Now you're heating the iron ring so that the iron ring expands and gets fitted into the ring, which means the diameter of the iron ring should change from D1 to D2. Is that clear, boys? The iron ring has a diameter to 5.231 meters at 27 degrees centigrade. Now this iron ring has to fit into the rim, which means its diameter should increase from 5.231 meter to 5.243 meter, which means you have to supply the heat energy. Is that clear, boys? So initially your ring is at temperature T1, which is equal to 27 degrees centigrade. When you heat the iron ring and when its diameter reaches from D1 to D2, what will be the temperature so that this iron ring now fits into the ring? Is this clear, boys? Is the question clear?
Yes,
Take
ma'am.
take D1 as 5.231 meter. So D2 will be equal to 5.243 meters. Temperature, initial temperature is equal to 27 degree centigrade. Now I have to give you the value of iron, so the specific capacity of solubles. Alpha, coefficient of linear expansion of iron, it is 1.2 into 10 to the power of minus 5 per degree centigrade.
Ma'am, should we know that?
No, this value will be given. None of the metal
Okay.
value, it will be supplied in the numerical itself. So what you need to find is you find what is delta T, which is T2 minus T1. So you find delta T. From delta T, you can find T2 is equal to delta T plus T1. So these two physical quantity you need to find. Find boss, find the value. Are you all calculating boys?
Ma'am, so when we are
Ma'am, but we
doing
don't have
with
delta T, right?
Huh? You need not convert it to the degree Kelvin because alpha is also given in centigrade.
so we can do the calculation with just D1 and D2?
Yeah.
Okay, ma'am.
Because the diameter of the iron ring is going to change from 5.231 meter to 5.243 meters because iron is going to expand. The iron ring is going to expand linearly in terms of its diameter. See, only when the diameter of the iron ring after expansion becomes equal to the diameter of the wooden wheel, only then this iron ring will get fixed onto the rim of the wheel. Is that clear, boys?
Ma'am, what will be the value of delta t then?
Okay, delta t, what is that? What is that you're getting, boys? Delta t, the value of delta t? Has anyone calculated the value?
Ma'am, 0.012.
No, 0.20 10 to the power of minus 5 is alpha. So what is the delta t? You know the formula for
Oh, okay,
alpha?
delta t, never mind.
Ma'am, is
What
it
is the
0.2 or 1.2 alpha?
Alpha is 1.2 10 to the power of minus 5. What is alpha, boys? It will be d2 minus d1, delta d, right? The original d2 minus d1 divided by d1 into delta t. So now find delta t from this equation. Instead of the length, it's the diameter. That's it. Boys, this is the formula which you need to use. Have you all completed? Boys, what is the value? How long will you take 7C? 7B? Abhishek, what is the value? What is the value, boys? What's the value for delta t?
Ma'am, I got it as 1.6 into 10 raised to 2.
1.6. How come, boys?
I think my calculation went wrong somewhere. I'll check it and I'll tell
Yeah,
you.
yeah. Yeah, just check. Dheeraj, a simple calculation you're unable to do. You people are taking so much of time. Jatin, Johan,
Yes, ma'am.
Jopal,
5.2 into
what is the
10.
value, boys?
Yes,
Just
ma'am.
right? 10 raised to the power. Just check properly. What is the problem you people are having? Was from this expression you find what is delta t. So alpha comes to your denominator, right? There is nothing in raised to the 10. Yes, please tell me what's the value. Such
I
mere
don't know the exact value, but I am
Okay.
doing it like 1 by 5231 into 10 raised to
Okay.
6. 10 raised to 6 is on the numerator. So I'm just doing that calculation. 1 divided by
Okay, do it.
5.
Even I'm
Okay,
getting
okay,
that,
fine.
and I'm doing what?
Okay, just make it as a whole number. You are
Is
doing
it
differentiation, yes?
227 degrees?
27.
Ma'am.
Yes.
Ma'am, I'm getting
What's
218.16.
200? Okay, final value. Okay, final
Yes,
value.
ma'am.
Are you talking about? Okay, it's correct.
Oh, yes,
When
ma'am. Yes.
delta T, I'm getting
Correct,
191.16.
correct.
Yes, ma'am. Even I'm getting that.
Fine, boys. You're doing so much of mathematics. You're doing a single differentiation, you're doing double differentiation with the exponential factor. I'm looking at your board over here. It's mere substitution and calculation. Why you people are finding it difficult? You're using UV method for your differentiation. What is the problem here for you all? For integration, you're using your UV method, right? Or for differentiation also you're using UV method. Haven't be something is wrong.
Not integration.
What have you calculated? Or should I do the calculation? Are you finding it difficult to calculate? If you're finding it difficult to calculate, I'll
Ma'am, can you
calculate.
show the calculations, please?
Okay, fine. Exponential solving numericals with exponential powers are difficult for you all, boys. So you have delta t must be equal to d2 minus d1 divided by d1 into alpha. So d2 minus d1, what is 43 and 31? Is it 0.012? Is that what you're getting, boys? Is that so? Numerator. Okay, fine. What is your denominator? It is 5.231 into 1.2, the 10 to the power. I'll put this as 10 to the power of 5. Or what I can do is I can make this as a whole number. I can make this as 12. 1 second. I'll make this as 12 into 10 to the power of minus 6. So that goes as 0.012 10 to the power of plus 6 by 12 into 5.231. Okay. Now this I can make this as a whole number. How many decimals? I have to move 3 decimals. So 12 into 10 to the power of 3 divided by 12 into 5.231. So 12 and 12 will get cancelled. So I'll have 1000 divided by 5.231. If you want to make it as a whole number, or approximately if I can take 52. So it will be, suppose if I go for 52, I'll just make, because I'm multiplying and dividing by 10. So now 52, you divide 10,000 by 52. At least that you can do. What is 10,000 by 52?
Does it come around 109?
So I'm just
Ma'am, 191.
190. Yeah. So boys, you should know how to use your exponential factors. Okay, fine. Fine, boys. Then in that case, I'll move for the next one.
Ma'am, can you tell the final answer of that question? The
218 degrees centigrade. 218.
Okay, ma'am.
This is the last topic of this chapter, which will be included for your annual examination, which starts from 21st onwards, not your students' evaluation. This is for the annual examination. There are 2 topics only from this chapter. One is the expansion of solids, that is volume expansion, linear expansion, superficial expansion. Now we are moving on to the expansion of liquids. Under that, you go for anomalous behavior of water. You know what you mean by anomalous, right? You know, in English, the term anomalous. Now look at this graph. Later on, we'll see the theory part of it. Now, let me take water in the form of ice.
Ma'am, do we write this?
Now, what's the last topic
You have to
coming
write
for
first. This
Annual
one, this one.
Okay, ma'am.
Whatever I'm doing right now, only till this
Okay,
is
ma'am.
will be for your annual examination.
Ma'am, do we write all this?
You need to write, boss. I'll just explain this. Now let us take water in the form of ice, say at 0 degree centigrade, right? Now it has some volume. Now look at this. The volume of ice at 0 degree centigrade is 1.0013. It is 10 to the power of minus 3 meter cube. Now what happens is that you're keeping on increasing the temperature. See, if you have a ice cube, if you supply heat energy, you're supplying heat energy so that its temperature will increase and it starts to melt. Correct, boys? It is converted to liquid. Now, will the volume of the liquid water, in this case it's water, will the volume of the water increases as you increase the temperature of the ice? Now think over, boys. You have a cube of ice. You are supplying heat energy. When you supply heat energy, slowly your ice will melt to water. So will the volume of the liquid, that is your ice, will it keep increasing or will it decrease? Now, what do you feel? Will it increase? Don't look at the graph. You just state.
Will it increase?
Or will it decrease? See, ice is going to, don't look at the graph. I don't want the graph. You just, what do you expect? If this is the case which is being given
No,
to you.
we're supplying heat here to the
Heat.
ice. Will the temperature,
Yes.
will the volume increase?
Yeah, I'm asking you whether the
Yeah,
volume
exactly.
of the
Yes,
it will
ma'am.
increase, right?
Volume will
Okay,
increase.
exactly. That is what we, yes, that's the thing what comes into our mind. That's the thing that generally comes to our mind. The moment you supply heat energy to the ice cube is going to melt. So solid will be converted to liquid. Naturally, the volume, the space occupied will increase. But look what is happening. As the temperature increases from 0 to 1 degree centigrade, your volume keeps on decreasing, right? Now it decreases and reaches a minimum at 4 degrees centigrade. Thereupon it increases. This is a peculiar behavior of water. There are certain substances which shows peculiar behavior, especially if you can remember, I think helium-2 or I don't remember, nitrogen-2. If you take this liquid in a glass tube, now what happens? The liquid, the moment you fill the tube with liquid, the liquid by itself will trickle up and moves down, trickle up the surface of the glass tube, and it itself flows out of the tube. This is some peculiar behavior of some substances, even the gaseous material. Same way, water is showing a peculiar behavior. As the temperature increases from 0 degree centigrade, the volume of your liquid decreases, reaches a minimum at 4 degrees centigrade, and thereupon it increases. Now, this is what we call it as the peculiar behavior of water, or what we call it as anomalous behavior of water. Now, this anomalous behavior of water helps the animal and the aquatic life deep inside the ocean, because when the surface of the ocean is being frozen, the liquid deep inside will never get, will be at relatively, will not freeze. Only the surface is going to freeze. The top layer freezes, but the bottom layer will not freeze, because top layer is exposed to atmosphere. So even when the temperature is low, the top layer, right, the volume will be less. The volume is less, it will contract. But the layers which are relatively lower will be at a higher temperature. So boys, the graph is important. When you're drawing the graph, you need not specify this values, boys. On the volume axis, on the y-axis, you just specify it is volume versus temperature along x-axis. The values you need not specify. You don't require the values, only the shape of the graph, and just show that where the temperature is minimum. So the density, the volume is minimum. At 4 degrees centigrade, the volume of the liquid is minimum. After 4 degrees centigrade, your solid will be converted to liquid and it begins to expand. Till 4 degrees centigrade, it contracts. Draw the diagram, boss.
Ma'am,
Values
is
need
there
not be
any-
specified.
Is there any reason why that happened?
There is a reason, boss, that goes beyond your. You have to go for all the other things like
Okay, ma'am.
latent heat. So many things have to be brought into picture. Just this is what is being stated. We'll see. We're running short of time. If in future, if we can, we'll go for it. Because this is there in your
Explain the
textbook.
properties
Yes,
again, like
yes, boss.
the application.
Yes. Application is this
Ma'am, can you
advantage.
explain the application?
Application in that sense, the top surface of the ocean is exposed to atmosphere. Boss, this is a top surface. It will be exposed to atmosphere. Say your temperature is somewhere 0 degrees, say to 4 degrees centigrade. Right? But the surface below will be relatively at high temperature, because the one which is exposed to atmosphere will be at low temperature. Now what happens is that at 4 degrees centigrade, say that when the temperature is 4 degrees centigrade, your volume of the liquid is less, or in other words, we can say density is high. Are you able to understand this, boys? When the volume decreases, when the volume decreases, then the density will increase. The material becomes dense. So when the density increases, the top surface will contract. This undergoes contraction. But the layer relatively below it will be at high temperature. Only the top surface will freeze. Why it freezes? Because of this behavior of water. Because the bottom layer, only the 0 to 4 degrees centigrade,
Ma'am, your voice is breaking.
the water. So the layers of water
Ma'am, we can't
below
hear
the
what
top
you're saying.
surface,
I think, ma'am,
till there is a problem, boys.
can ma'am hear us?
Yes, ma'am.
Ma'am,
Can you
whatever
repeat?
you
Here,
said,
but still,
ma'am, whatever you said like a while back, we couldn't hear.
now is it fine?
Now we can hear you.
Yes, ma'am.
Boys, the top surface of your ocean is always exposed to your atmosphere. So say your atmospheric temperature is somewhere around 0 to 4 degrees centigrade. Because of this peculiar behavior of water, the water level on the top surface will occupy less volume. In other words, it becomes denser. Denser means what? The top surface will contract, will freeze. Contract means it freezes compared to the surface below it. So your aquatic life or plant life or animal life will not be able to survive on the top surface. You could have seen all your aquatic life and animal life always exist below certain level of your ocean, because the temperature over there will be relatively high. Water will not contract. Volume is more at a certain depth, below certain depth. That is what they mean. See, this peculiar behavior of water is not going to apply throughout the layer of your ocean. Only top surface will undergo this and will exhibit this anomalous behavior of water, not the layers of water below the ocean level. So if I have to go for density versus temperature graph, so at 0 degree centigrade, your density will be minimum compared to that at 4 degrees centigrade. So your graph at 4 degrees centigrade, volume is less, volume will be minimum, but density will be maximum. So density of water at 4 degrees centigrade, it will be maximum. So volume versus temperature graph, or it can be density versus temperature graph for your water. Fine, boys. So you have the graph over here. It's there in your textbook, boys. So what is left is specific heat capacity. Have you learned about do you have an idea about specific heat? Do you have an idea of specific heat capacity?
No, ma'am.
No, ma'am.
So we'll just go through what you mean by specific heat capacity, right? Then a bit of calorimetry. But these are not included in the examination, which starts from 21 onwards, right? This will be for students' assessment work. So we'll just go through what you mean by specific heat capacity, and then we'll start with thermodynamics terms.
Ma'am, isn't specific heat like cancelled from portions?
No, it's not cancelled from portion. It is still there in your portion, but the thing is that we have to ascertain certain topics for students evaluated work, where you will just go through the textbook work, or else you can go beyond that also, some research work. So we need to give certain work to you so that we can assess. That assessment will be done by you, rubrics will be provided. So we thought we'll not go beyond text. Anything you need to refer should be within your text as well as within your reference book. Some might go, you can take a chance of going beyond the text also. So we don't want to, what to say, tax you. So we thought these subjects which are already there in your textbook, which will not be included for the portions, we thought we'll give those topics to you. So this weekend, it's already there in your Phoenix we have uploaded. Just go through those topics, just to have a look of. Fine, boys. So for the examination, only these two topics here.
Ma'am, can we leave?
You can leave.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, boys.